In graph 19.6, we showed how wealth effects can mask the substitution effects that cause deadweight losses in labor markets when wages are taxed. We'll turn here to a similar issue, subsidies of capital, where again wealth and substitution effects are likely to point in opposite directions, and an unawareness of this might lead to the misleading conclusion that there are no deadweight losses from subsidizing capital under certain circumstances. Suppose, for instance, that savers who supply capital to the market are unresponsive to changes in the interest rate. We argued in earlier chapters that that's a plausible empirical assumption. That would imply a perfectly inelastic capital supply curve, as drawn here. The benefit of a subsidy, just like the burden of a tax, is passed to that side of the market that is relatively more inelastic in its behavior. Here savers are perfectly inelastic, which means that the benefit from the subsidy for capital is entirely passed to savers, who now get an interest rate of R star plus S, whereas previously they got the interest rate R star. If you have trouble seeing how this comes about, draw the supply curve almost perfectly inelastically, insert the subsidy wedge to the right of the equilibrium, and then straighten out the supply curve and see what happens. It appears that there's no deadweight loss triangle like the one in graph 19.5b for the subsidy. But the reason for this is again that substitution and wealth effects are offsetting each other, and it is the substitution effect that gives rise to deadweight losses, but is masked in the market picture here. To see what is going on underneath, we begin with the before and after subsidy budget constraints for a saver. After the subsidy is introduced, the saver operates on the magenta budget and optimizes at point A. Since savings behavior for the saver is perfectly price inelastic, we know that this same saver optimized at point C before the subsidy was introduced, consuming the same amount today and thus saving the same amount. From point A, we can see how much in future consumption this saver can undertake after the interest rate subsidy. From point C, we can see how much in future consumption this saver could have undertaken in the absence of the subsidy had she consumed the same amount today. The difference between those two amounts must be how much the government is contributing to the future consumption of this saver through this subsidy. The vertical difference between A and C is then equal to the government payment G for this subsidy. We can then ask how much the government would have had to give this consumer in cash without distorting the interest rate to make her just as well off as she is under the interest rate distorting subsidy. In other words, we ask how much do we need to shift the initial blue budget out in a parallel way to reach the indifference curve UA. The resulting green budget tells us that if we gave this saver just cash, enough to make her just as happy as she is under the subsidy, she would choose bundle B. The vertical difference between the blue and the green budget is then how much in cash the government could have given us in the future to make us just as well off as we are under the price distorting subsidy. In other words, how much we could have gotten in lump sum cash as opposed to a price distorting subsidy. This distance is indicated here as L. Since the government ends up paying the vertical distance G when it could have accomplished the same increase in happiness for the saver by spending the lump sum amount L, the difference between G and L becomes the deadweight loss. The amount of savings is the difference between the consumption that could have been undertaken and the consumption that actually was undertaken today. That amount is indicated here with the magenta bracket. And this amount is unchanged as the interest rate changes because they're offsetting wealth and substitution effects. We can now use what we've learned in panel B to show how in panel A the actual deadweight loss is hidden by the masking of the substitution effect through a wealth effect. We begin by again replicating the inelastic supply curve, but we now indicate it explicitly as an inelastic uncompensated supply curve. We then insert the compensated capital supply curve that corresponds to the utility level UA in panel B. This has to pass through point A because the bundle A in panel B lies on the indifference curve UA, and it has to be upward sloping because the substitution effect unambiguously says that as interest rates go up, savers save more. Bundle B in panel B lies on a budget constraint that has the undistorted interest rate R star, and therefore must lie at the level R star on the compensated supply curve in panel C. The subsidy payment G that the government actually has to make under the distortionary subsidy is equal to the per unit subsidy S times the amount of savings undertaken. This is equal to the area A plus C in panel C of the graph. The amount that the government could have given in lump sum cash can also be determined as an area in panel C. To see this, consider the fact that the individual is equally happy at points A and B. But at point A, the saver has a surplus that's bigger than the surplus at point B by area A. That difference must be the lump sum payment that the government made to the individual at point B, otherwise the individual wouldn't be equally happy, as indicated by the fact that both these points lie on the same compensated supply curve and on the same indifference curve in panel B. The lump sum subsidy that makes the saver equally happy is therefore equal to the area A, and the deadweight loss is the difference between G and L, which is the difference between the area A plus C and the area A. Thus we're left with a deadweight loss from the distortionary subsidy equal to the magenta triangle C. The amount of savings undertaken by this saver then remain unchanged as the interest rates change, leading to the perfectly inelastic supply curve. But the deadweight loss triangle is hidden because of offsetting wealth and substitution effects. In both labor and capital markets, there is therefore good reason to worry about offsetting wealth and substitution effects, because in neither market is the quasi-linearity assumption a natural one.